Hello and welcome back. My name is Amir, and in this puzzle we are going to solve puzzle on day 14 of Advent of Code 2022. So let's get started then. Okay, in this puzzle the distress signal has led us to a giant waterfall, and there is a path behind the waterfall that will lead us to a cave that will probably lead to more puzzles in the next days. As we pass along, we will see that sand is being dropped from a point into the cave. So we need to scan how much sand is being dropped and if we are going to be trapped inside the cave or not. So when we scan, we will get something like this. This is our input to our puzzle that shows the position of the rocks. This means there is a rock from this point to this point. Or in other words, there is a stream of rock from this point to this point. And each line has a bunch of connected lines together. So we have a bunch of rocks from this point to this point, and then from this point to this point, and then from this point to this point. So if we draw these lines together, we will get to something like this. That shows the positions of all the rocks. So this is our first task, to compute and understand what is here and convert it to something like this in a grid. Then there is a point that the sands all drop from that point. The sands drop one at a time, and the second sand will only drop when the first sand has come to the rest. And the sand particles all act similarly. They will do like this. They will drop down until they get to a point where they cannot go down anymore. Then they will check their left, and if there is position on the left down, then they will move there. If that is taken already, they will try to go to the bottom right, and if that is completely taken, then they will stay still. So let me give you an example. Suppose that our first sand starts here. It will drop down and end here. There is a rock here, so it cannot go down anymore. There is a rock here, so it cannot go bottom left, and there is a rock here, so it cannot go bottom right anymore. So it will land here and stay. What would happen if the second sand drops? It will drop down and will reach here. It cannot go down anymore, but it can come to the left, bottom left, so it will land here. And from here it cannot go anywhere else, so it will stay here, come to rest here. The third particle will come down here. There are already two sand particles here, so it cannot go down anymore. It cannot go down to the left anymore, but it can go down right. So we will have three sand particles here, like this. And we will continue dropping sounds. So this is the second one, and this is after 5 sounds that have been dropped. Then after a total of 20 units of sand, we will get to this point. Then we can have 2 more units of sand, which will end up here, and the other one will end up here, like this. And from this point on, whatever the sand that we drop will end into the abyss or into the void. So it's like this. After all the 24 sounds have been dropped, the sand will come here and will follow this sign that is here. So it will come here, 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 and then reaches here, come down and go left, and will drop into the void. So given our input, which is the position of rocks, like this, we need to figure out how many sands will drop before all the rest of the sands drop into the void. So using our scan, Simulate the falling of sand. How many units of sand come to rest before sand starts flowing into the abyss below? So the point here is that if a drop of sand passed the last row of rocks, like here, so if a drop of sand lands here or lands here, it will go down to the abyss because there is no more rock on its way to to avoid it from falling down, so it will fall down. So this is what we should consider. If one of the sands land here by some magic lands here or lands here in this puzzle, it will surely drop into the void. So this is what we should consider. So let's go and start coding. Okay, so let me first grab the lines by splitting my data by the new lines. Okay, then I will have a set of the places that include the rocks. So I will have a set like this. Then I would say for line of lines, for each line, I would need to figure out the coordinates. It will be an empty array. Then for split by this, for every one of them get the x and y from splitting that str code by dot split by this, and then map it to number, and then I need to push it these values like this. So let me see what this will give me, coords, and then okay, now I'm getting all the coordinates like this, and now I need to read these coordinates that are much more readable and iteratable from one to another and provide the field set. Okay, so let's do that. So we would say for let I starting from 1 until we get to the length of coords, like this, do a bunch of things. First, give me the coordinate of x and coordinate of y. From that coordinates at index I, and then give me the px and py, which is the next coordinates or the previous coordinates. So I'm starting here and I'm getting current, and this is the previous one, and I'm drawing from this one to this one, or this one to this one. It doesn't make any difference because I will be using abstract value between the two. So I'm getting this two, and then I say if cy is different from py. So if we are going like this, we are going vertical, and when cy and py are different, like in this example, these and these are different, then these and these are the same. Okay, so if these two are different, then the thing that I need to do is have another for loop. I would say for y, and I'm getting the minimum of the two values of the cy and py, like this, and we will go up until we get to the maximum of the two values, math.max of cy and py, and we're adding 1 to the y, and what we do is that we use the add method for the sets to fill the set. And as the JavaScript does not have any tuples, I need to store it as a string literal like this, and like this, and this will be cx, and this will be cy. Okay, so this part is done. The other part is that when cx equals px, then we would have some x that will go from cx and px minimum to x from cx and px maximum, and we are adding to x, and we are adding the cx, and not cx, this is x and cy, and this is cx and y, because y is the thing that is changing, and cx is the thing that is always there. Okay, so far so good. And when this for loop is finished, then we have the coordinates, hopefully. So let me log it here. First clear this stuff, and then log the field. Yep. We are getting all the points here. Cool. Okay, what is the next step? So if you remember, I said that if one of the rocks appear here or here, which means that its y position is the same as the y position of the last rock, like this, or in other words, if the y position of this sand rock or this sand rock is the same as the maximum y that we can find in the set of the rocks, then it will fall into the abyss. So we need to find the maximum value of y here. So okay, I will call it max y const, no, not here. Here I will call it max y, and I will say it will be math dot maximum of something. I first need to convert this set to an array, but I need in this array to do another thing, and that is to map it and get only the y values. So I would say like x or whatever is get me the number of that x, which is split by this, and then split by this, and then get me the number 1. So what I'm doing here is that for each of the items that are in the field, I'm mapping them to be a number. After that, they are split by commas, and I get the first one of the arrays, and then I can get the max y. So let me see if I did it correct or not. Node part 1. So I get 9, which is the correct one here in this input. Okay, cool. So what's next? The next thing is that I need to now simulate the sand drop. So I would call the function simulate. Let me call it simulate sand. And it has no input. And we are starting from position 500, which is this position. So let me have that in a array like this, and I will say this is 500 and O. Then while our y is less than or equal to max y, so until we have not reached the abyss, try dropping down. If that has x and y, actually y at position +1, then add to the y and continue. So what I am doing here is that I am checking if the next space or the space below the sand, like here for example, if the space below the sand is empty or not. If it's not empty, then we can drop down. That's what we do here. We add 1 to the y. So this part is done. Then I need 2 more ifs for going to the left and going to the right. If x minus 1 and y plus 1 is not taken, then drop to bottom left. And if that is not possible, but x plus 1 and y plus 1 is possible, then drop to the right, like this. And if none of these is possible, then there is nowhere to go, so just add that to the field, because it will come to rest. It would be position x and position y. Position x and like this. And when this is done, then you can return true, saying that okay, I have placed this one. Okay, so this is done, but if it passed the y max and cannot come to stand still, then we should return false, which means that it has fallen into abyss. Okay, makes sense. So we are starting at this position and we're checking while y is not reaching to the end of the array of stones or rocks, and if we could drop, then we will drop. If we couldn't drop anymore and we haven't reached the end, then we will stand still and we say, okay, this one is dropped and stopped, and then we will return from this whole function. Otherwise, if we have passed, if we came to the max y, or if we have passed the last rock, then we return false, saying that okay, this piece of sand will drop into the abyss. Okay, so this part is done. The only thing is that I need to count the number of the sand particles. So I would say the result is try to simulate the sand from the starting position. If you couldn't, if you didn't come to stop, then break. We are going to the abyss and we have already solved the puzzle. Otherwise, if it come to rest, does add to the answer one more and then try again. After all is said and done, then we need to log the answer. Okay, let me clear this out, and we came to 24. So let me check. Yes, this is 24. So let's get the correct input and try with that. Then save and do this. So this is the last y, and this is our number of sands, 828. Let's go here and come here and try this. This is correct. Let's get to part 2. Okay, in part 2 we realized that we misread the scan. There isn't an endless void at the bottom of the scan. There's floor. And we are standing on it. Okay, so we don't have time to scan the floor. So assume the floor is an infinite horizontal line like this, with a y coordinate equal to 2 plus the highest y coordinate of any point of your scan. So it's here plus 2, which will be here. In the example above, highest y coordinate of any point is 9, that we figured out, and so the floor is at y equals 11. With the added floor, the example above looks like this. Then, to find somewhere safe to stand, you'll need to simulate falling sand until a unit of sand comes to rest at this. So one of them drops and cannot drop anymore, stand where it was, it cannot go anywhere, and there will be no more sand to be dropped. There will be like 93 sands that will fall before that happens. Now we need to find out how many units of sand come to rest before the last one cannot be dropped. Okay, so let's go and do that. I will copy and paste from here to here, clearing here. Then there is a bunch of things that I need to do. So what are those things? My reading is the same. For each line of code, this is the same. Then y max is also the same. I don't need to console like this. First I need to check, after that I have this, I need to check if I cannot drop anymore. So if I will check that if field has this value x and y, then I cannot drop anymore. I will return the x and y, which is the position that the sand has fallen into. Then again, if it can drop down, it will drop down. If it can go to left, it will go left. Otherwise, it will go to right. Otherwise, if it cannot do anything, then it will break from this loop. And then we would say, okay, this has landed here because there is no abyss to go down. So we will at the end return the position of the fallen sand. Okay, the answer is the same, and then while we are true, we will do this. We will say, okay, give me the x and y from the sand dropping simulator, and then add that to the field set, and add one to the answer like this. And if our x is equal to 500 and our y is equal to 0, then we break from this one as well. Okay, so we will get to this value, which is the correct one. So thank you again for watching my video. Have a great day and see you tomorrow as well.